Hi, good day to our dear lecturer, Dr. Jumail. My name is Kang Wei Kiat, and our group project title is Food Ordering Application, FoodRing. So before I begin my explanation on the application walkthrough, I would like to explain on what our application does. Initially, our group plans to use the camera application to scan the QR code provided on the table to locate the consumer's table. Then, after accessing the QR code, consumers are able to select the food from the application. The camera application also allow the employees to create new food in the menu and also to take the picture of the food using camera. However, due to the time limitation, we could not implement the camera function into the app, which causes the ordering part from multi-user to be undone and view multi-order from employee to be incomplete. However, we have already done the basic function of the app, such as employee are able to create the food order from the menu, and also a consumer are able to order food from the food menu. So right now, allow me to walk through on the application. So when the user select on the application, there will be a splash screen, and moving on to the main page of our application. So if the user is a consumer or customer, simply click on the Let's Start Order, and over here the application will fetch the food data from the Firebase. So over here, the customer can straight away order their food. For example, spaghetti with chicken bolognese, 2 portion, and add to cart. Next, fish fillet, 2 portion, add to cart. After the consumers are done with ordering the food, they can view their food in the cart icon. Simply press on the cart icon and they can view the food that they ordered. So over here, there is 2 portion and 2 portion. So the total price can be seen over here, which will calculate the total price of the food. So when the user press on the confirm order, it will again shows the total price of the food, and the functions of from the consumers are done. Oh, besides, the consumers can delete the food they ordered simply by long pressing on the food, and the total price will change again. Right. So moving on to the employee side. So if the user is an employee, they will need to log in. And over here, we are using the authentication from the Firebase, which we manually included the email and the passwords. Okay, so after logging in into the application, this is the main page for the employee. So the user are able to view their own user profile, and they can do the name changing and also to change the password. However, these functions is not available in our application. It's just for the display purposes, and it is not connected to the Firebase. So if employee, they can view the menu. So over here, our application will fetch the food from the Firebase. So employee, the user can view all the foods. So when the user select on the particular food, they can edit the food name, the price, and the food description. So example, I would like to delete this chicken bolognese and meatballs, probably with fish. And the price, I would like to change to 35 ringgit. Okay, that's it. So when the user selects save, and it will be updated into the Firebase. So over here it is changed. And besides, if the user would like to add new food, they can simply click the plus icon. For example, Coke. Get application. Drinks. So for the picture, it is not available. Press save. So as you can see, the new food is created and it is updated, is reflected on our Firebase as well. So next, the user are able to delete the food as well by swiping the food to the left, and it is deleted. So moving on, our application has also the order which I've explained earlier on. However, it is available in mock data. So the user are able to select the order complete after the food is, I mean the food reached the table. And over here, user can view all the tables that are occupied, empty, or in the cleaning progress. So when the table is empty, it will change to cleaning in progress. When it is done cleaning, it will be empty. So there is a push notification which is left undone because it serves no function on the due to the time limitation. So lastly, on the lockout. Alright, so that's it for the application walkthrough. Thank you.
So the front-end architecture that we adopt in this project is using model view controller pattern. The model component corresponds to all the data related logic that the user works with. This can represent either the data that is being transferred between the view and control component or any other business related data. For example, in our case, the model consists of customer, dining table, food item, order, and order item. The customer object will get the information from the from the will retrieve the customer information from the database and manipulate and update it to the database or use it to render data. So next, go to the view part. The view component is used for all the UI logic of the application. For example, the customer view will include cart, data, customer page, and food detail. When the customer log in, they will first go to this customer page. Then they can see list of food item. And once they go click on each food, they will go to the food detail and see the food detail. And then once they check out, they will go to this view. So basically, view is handle the presentation layer. So another one is for the menu. Menu is for the admin and the employee. So next, for the controller. Controller acts like an interface between the model and field component to process all the business logic and incoming requests, manipulate data using the model component, and interact with the view to render the final output. For example, in our case, we're using these food item data services to act as an controller. So we use the get all food item. So it will retrieve the data from food item and then send it to this customer page. So as you can see here, we declare a final data service for item data service. So we're using this function get all for item. So once the user login, we will get all the food item. We're using the future builder. So for the backend architecture that we adopt in this project, we're also using model view controller, as you can see here. Controller in the model. So the controller is handle the request sent from the user and get the data from model, and then you will send it to the view part. Our controller have customer. Each controller they will have get, post, delete, patch. Basically all the controller it will consist of the CRUD operation. Inside the model, declare each of these. So this is for our front-end architecture, and for the back-end architecture for our project, which is food order system. Okay.
Now I am going to talk about the step management. The approach we use to manage the step in our project is step food widget and future builder. As we know, Flutter use declarative approach in step management. All widgets are immutable, and the widget in Flutter will only get rebuilt when something triggers it. We use step food widget because it has the capability to get rebuilt more than one time. It gets rebuilt by using the setStep method, and it replaces the existing one with outdated step from the step object, and this is how we manage the UI changing in our project. The second approach that we use is future builder. Future builder is used because we need to fetching data from the Firebase service. It requires some time to fetch the data from internet. So in order to avoid the UI being broke, we need to structure our code in a synchronous manner, and this is why we use future builder in our project. And now I am going to explain about the component involved for the step management that I have mentioned. For the step widget, it is attached with a step object. The step object is mutable, and each step object has a method called setStep. This method is involved when something triggers it, and it will cause the step widget to get rebuilt and replaced with the new one. For example, in our project, the add new food menu modules, we need to fill in the food menu form. Let's say we enter the value for the food name. The on-change in the food name will trigger the setStep method, and it will update the value that I have entered from the food name to the UI screen accordingly. For the future builder, there are two properties involved, which is future and builder. Future is the place to put the data source and used to handling the data transaction. It grabs the data using HTTP, and the result from the HTTP is a form of future. And then the next one is builder. Builder is for creating the UI when future complete. It will get triggered, and this is how the data link to the UI. The future builder will render the UI accordingly once the future is done. So for example, the view food menu in admin page, The future property is used to call the data service, which is get all food items from the REST API service. If it completed fetching data, then it will return the food menu screen with a list of food menu. Else it will return the fetching data screen and keep routing until it's done fetching the data from the Firebase.
For the authentication part, we are using the authentication service provided in the Firebase to handle the authentication. There are three kinds of user in our project. One is the normal user, which is the restaurant client, but they are not requested to authenticate themselves in order to use our applications. The second one is the restaurant staff, and the lastly is the admin of the applications. They are able to manage the order received and the food item menu in the restaurant. So authentication is very important for the business. And then by using authentication in the Firebase, the user can authenticate themselves with their own email and their own unique password to log in into the service, into the system for managing the order and the menu item. For the back-end technology of this project, we are using REST API service with Firebase and Firestore to handle the data that we store in the server. Firestore is one kind of non-SQL database where the data is stored as a list of collections, and each collection will have its own a list of documents. In the case of our project, we are using Firestore to store the list of food items available in the menu of a restaurant. So the collection is named food item, and there will be a list of documents stored in the collection. For example, the document 1 is burger, and document 2 is chicken chop, and so on. So as we mentioned just now, we are using the REST API to handle it. And then we use the REST API to when we use the REST API to access the data from the backend service, the application will send a HTTP request to the Firebase according to the REST API URL that we code into it. Once the Firebase receives the HTTP request from the applications, the controller in the Firebase will process the request according to the request method, whether it is get to request data, post to create new data, put or patch to replace or update the data, or delete to delete the data. The controller will get the data from the model class to moderate the data from the model class, and then the controller will also return the data back to the application using the HTTP response. The data stored in the HTTP request and response is in the form of string JSON. We need to decode it into map and further convert it into object before the apps using it. Using the same logic, the apps will need to convert the object into map and then further encode it into string JSON before sending back to the backend.